recording. There we go. And now you won't have to stare at this ugly mess. Look at this clean, beautiful sheet of unused paper. I'm actually gonna go to the notes for 1 sec. So I wanna make sure we're on the same page. No pun intended. How do I do this again? Share screen. Okay, so I'm pretty sure this was last day. Is that correct? Page 20, 1 and 3 to 8?
Yeah.
Does anybody have any questions from that? Somebody just leave? 1, 2, 3, 4, 5, 6. Who left? I don't know. Curious though. Ryan? No, Ryan's there. Anyways, okay, someone left. I hope they weren't offended by me asking if there's any questions from the previous assignment. Let's go to the next assignment. Today's notes, acceleration. I'm just going to show it kind of this way instead of tabbing through the, whatever it's called, the builds, the transitions, because I seem to run into trouble when I'm using Keynote. So anyways, acceleration, that is a change in velocity, up or down, speeding up or slowing down. Super curious who it was that left. I think I've only seen you guys in person once so far. I don't remember who's all in class. Is anyone still writing?
Yep.
Okay. How about now? Where are we at? Anyone still writing? No? All right. So I guess it's class change or something in the hall. It'll be quiet in a second. A velocity time graph describes the motion of an object with that WRT is with respect to velocity. Velocity time means, you guys can see my cursor, right? As I move it here. Can anyone see this? Someone say yes if you can see this, pretty please.
Yep.
So on a graph, like, so this is the vertical axis, this is the horizontal axis. The horizontal axis is time, vertical would be velocity. I know I've kind of mentioned that 4 times, almost always on the bottom. Uniform velocity means it's going to be a straight line. You will see, and you don't have to kind of write this down right now, but from a velocity time graph, slope is what gives you acceleration. From a displacement time graph, slope gives you velocity. Uniform means it's going to be a straight line. If it's zero acceleration, it's going to be horizontal. For on a acceleration time graph, it'll be horizontal. Anyways, I don't need to keep saying this stuff. I'll just show you the graphs that we are. How do I make my screen fuller? The graphs that it's referring to. So this is page 21. So notice right away, you'll notice the graph is a curve. So this is displacement over time. Graph is a curve. On any graph that curves, the slope or steepness of the graph changes from one point on the graph to another. So the slope is constantly changing. If you were to use, I do a little ruler. I don't know how much experience you guys have with tangents, but kind of like this point-ish on the graph would be represented by this slope. That point right there, that would be represented by that slope, and so on. You kind of follow the curve of the graph, and that will tell you what the slope is. So the slope is constantly increasing. That means this is displacement time. The velocity is constantly increasing. Graph is a curve, blah, blah. Since the slope in graph A, which is this one, is constantly changing, the velocity is not constant. And since the graph lies above the x-axis and its slope is increasing, the velocity of the object is also increasing in a positive or eastward direction. Okay, the slope is getting sharper. That means it's increasing and it's going more east. The only, well, not the only difference. Notice also, like in the picture there, person's going downhill to the right. This person here is going downhill to the left. So they're still, sorry, this camera is good. It's just tricky. It's also east here. If this was west, the graph would look like the other one. Everything else is the same. Since the graph lies below the x-axis and its slope is negative but getting steeper, the object is speeding up as it moves in a negative or westward direction. Okay, it's speeding up over here too, but it's going in an eastward direction. Any questions about those two? All right, turning the page. Okay, so for this one, you got this human going, that is steep. That's not possible. Anyways, now notice this one. Try and imagine before you kind of read too much of it. What do you think is going on? Glare, hey? I don't know what to do with that glare. What do you think is going on here? The displacement is increasing. It is going further and further east. But what does this type of curve tell you? It tells you that it's slowing down. It's going fastest here, slowing down, because if it levels out and it's totally horizontal, that would mean its displacement doesn't change over time. If it's like at 7 or who knows, whatever, however many meters, not changing would be horizontal. If it comes down, that means it's going back towards kind of wherever it started. If it's coming down like this, it's going to be moving west. The slope would be negative, so it would be moving west, kind of like this one is. So it's slowing down. This one's slowing down as well, but in the other direction. This one's going west, this one's going east. It's constantly changing, so the velocity is not constant. Whether or not the acceleration is constant, you can't tell just by looking at those. Questions? Like I said before, there are no dumb questions. Please ask.
Is east always positive?
You know, let me not screen share for a second. It's probably, the short answer is no. The easy answer is yes. So, and the reason I say that is, so if we have this is west, this is east, this is north, this is south. If we say that up and to the right is positive, and we just always say that, that's totally okay. That's totally okay. There's nothing wrong with it. The only reason people will not always say that is if you're talking about something going in the westerly direction and it's always going west and everything you're doing is west, it gets tiring to put in negatives all the time. So as long as you remember it's west, you can just keep it all the same. When it's changing direction, doesn't matter if you decide, well, I like my east to be negative, my west to be positive, or whatever, who cares, doesn't matter. But if you're changing direction, the sign will change. And that's when it matters. Does that make sense?
Yeah.
So like if I say I am, which way am I facing right now? I am facing north. And if I walk north 50 meters, I could say 50 meters north. If I could also say, but this is where it gets silly, but hopefully it makes sense. I could say I'm going negative 50 meters south. Well, that's just silly. So we generally kind of use positive when it helps. But if anytime we change direction, we need to remember the signs. It really kind of matters to me, I think. We're going to do a lot of kind of projectile motion. So if something kind of gets kicked off a cliff or something and then falls down. To me, I always like to use acceleration because acceleration is down 9.8 meters per second squared, down or whichever direction. The acceleration to me, I will make it positive when it is going with motion. So if you're standing on a cliff and you throw something straight down, I like it that the initial velocity is going to be positive because it's going in that direction, and acceleration is positive. It's going with initial velocity. It just makes it easier. But if you throw something up, that initial is going to be positive, which means acceleration is affecting it in a negative way because it is opposing motion. I feel like I'm getting ahead of things. I should probably just leave it here. We will get here. You don't have to memorize any of this. I'm just trying to tell you how it gets a little bit complicated. Not really, but just it helps with direction. Does that make sense? Whoever asked the question?
Most of it, yeah.
Most of it is, keep asking if I'm not doing a good job. It really, in all honesty, it's up to you because your final answers, they need the direction. So like 50 meters north is the exact same as negative 50 meters south. The direction is the important part. When you're doing the math, like you don't punch in north into your calculator. And we're going to see it in an example today. I'll show you kind of how it matters. So it's just that if you're using north as positive, then you're going to use a positive number. When the answer comes out of your calculator, you remember north. If you're just punching in number stuff and you're not keeping track of direction, that's when the signs will kind of come back and bite you. Does that help?
Yeah.
We're gonna talk about this a little bit because it's going to change directions in some of the examples we're going to do today, and that'll probably clear it up a bit. Thank you for asking. Okay, what are we doing now? Sharing the screen to notes. Please don't anybody ever feel bad about asking questions. All right, I'll be quiet. This is not a bad thing. I know I'm pretty confident anyway. Ada Shorthands is the slowest note taker in math. Who is it here? Is it you, Kate? I'm not picking on anybody. I just want to know. Let's put it this way. Instead of answering, Kate, can you tell me when you're done taking this down?
Okay.
Just give me an idea because I can't watch people. If I'm in class, I can see when people's hands are moving here. I got nothing. Can you guys hear that weird sound, that squeaky sound? No? Okay. It's my stomach. Seems kind of loud for some reason.
I'm done.
Thank you. Anybody else still writing? Perfect. Kate, you're going to be my go-to. So I'm just sitting here staring at the wall because that's what I do when I wait. Wednesday, we have early dismissal. Now, you guys aren't in the building, so it doesn't really affect you. Are you okay if we just keep class time the same, even though it's early dismissal? If you were in the building, things would change. But are you guys okay if we just keep the same times on Wednesday?
Yeah, that makes sense.
I think it'd just be easiest, and anybody who kind of can't make it or whatever, like I said, I'm recording it, so. All right, so the slope of a line in a velocity time graph is average acceleration, represented algebraically in meters per second squared. Now, it says like this is units, meters per second squared. It doesn't say, I could almost actually add just to be sure. Okay, I'm gonna have to fix that. But this will always include a direction unless it asks for just the magnitude. Oh, how do I do this? I don't want it superscripted. What? Okay, I'm just gonna leave it superscripted. It's not supposed to be, so maybe I'll change color just so it doesn't get super weird for anybody. Oh my word. I have not used Keynote in too long. Anybody else bored by this? Me too. Okay, good enough. You go away. Get out of here. Okay. Anyways, there's always going to be a direction. We don't know until we know. When we a little further along, it won't be just north or west. It'll be like north 32 degrees west and blah, blah, blah. So they have vectors. That's what tells you there's a direction involved. So it's the change in velocity over change in time. This is the area under a velocity time graph is displacement. We'll worry about that more later. It's just kind of a note. So it has here, consider tutorial 1, page 220, page 23, 2 on 25, and then look at these others. And then it says, do the practice questions. I'm going to do these with you now. You can look at this stuff after. So let's write this down so I don't forget. 3 on 24 and 2 on 25. So let's do that. Okay. Ugh. Set myself up. Okay, so page 24, number 3 says, if you have your textbook, great. If not, no big, I have. It says a squash ball with an initial velocity of 25 meters per second west. So I'm going to do VI equals 25. I don't write the units down because I just don't. It just takes time. You'll get to know which units you need for which answers. If you want to write the units down, please do. The direction is important though. Initial velocity 25 meters per second west, because that's going to tell me if it's positive or negative. Hit by a squash racket, changing its velocity to 29 meters per second east. So VF, final velocity, is 29, but now it's east. If these were both west, so this goes back to your question, I think it was Nathan that asked, here now the signs are going to matter. If these were both west, I wouldn't care. If they were both east, I wouldn't care. But it's going to change the sign because they're changing direction. So this is where it matters. Time is 0.25 seconds. T equals 0.25. What is the average acceleration? Well, acceleration is velocity over time. Again, I'm doing the short version just for time. Now, delta V is VF minus VI, final minus initial over time. So if we are going to, red marker, if we're going to use west meaning negative, then this is going to be negative 25, and this will be positive. If you decide to go the other way, that's totally fine. It will make sense, I promise you. But this is just more conventional. So final velocity is positive 29 minus initial velocity is negative 25. So it's 29 minus negative 25. This is why signs are important. Over 0.25. So 29 minus a negative is 29 plus 25, which is 54 divided by 0.25, 216. And it's acceleration, so it's meters per second squared. And the direction, because it's positive, and we decided in the beginning that east is positive, it's 216 meters per second squared east. Now also notice everything is 2 sig figs, so we got to change it to 2. So that would be 220 meters per second squared east. Textbook is using scientific notation, which is totally fine. 2.2 times 10 to the 2 meters per second squared east. Goodness gracious, you don't need to write out so many different answers. Either of these is fine. This matters more. We're going to get into numbers that are to like times 10 to the negative 31 and stuff like that. Then I don't want you writing it all out. That's when we'll go here. Any questions or problems with that? Is everybody okay? Anybody still writing? All right, let's go to page 25. There's number 2. Page 25. Says a speedboat experiences an average acceleration of 2.4 meters per second squared west. So acceleration is 2.4 west. The boat accelerates for 6.2 seconds. That's the fancy way of saying time is 6.2. And as a final velocity, VF equals 17 meters per second west. Now notice they're both west. What was the initial velocity of the speedboat? So I don't want to confuse you, but I'm going to show you that I'm not going to use a negative for west here. I don't want to. I'm adding something I don't need to. They're both west, so I don't need to. If you guys want to, that's totally okay. What you'll see though, is if we get a negative answer, because we're going to be solving for VI, I assume. What does it say? Yeah, what's the initial velocity? We're going to be solving for VI. If we get a negative number, that means it's east. Because if we're using west as positive here, a negative number will be east. If you want to, as we go through this, you're like, no way, man, I'm always using negative for west. That's totally fine. Then make sure you put a negative in front of these numbers when we do it over here. All right, so acceleration is VF minus VI over T. Let's put in the numbers we know. A is 2.4. VF is 17 minus VI, that's what we're solving for, all over time, 6.2. Multiply both sides by 6.2. Then I'm going to subtract 17 from both sides, and that's going to leave me with negative VI. Instead of me just skipping steps, I'll show you. So it's 2.4 times 6.2 minus 17 equals negative VI. 2.4 times 6.2 equals that, minus 17. Oh, here we go. So negative 2.12 equals negative VI, which means 2.12 equals VI, which means our initial velocity was west. Okay, if our answer was negative, like let's say this was a positive number equals negative VI, that means it would be negative 2.2 equals VI. But this means it's west. And if we're doing sig figs, the initial velocity is 2.1 meters per second west. Any problems? Nathan, it was you asking about signs, right? West and east and stuff.
Yeah.
Is this making sense?
Yeah.
Anybody else? Any issues for anyone? No, everybody's good. All right. Anybody still writing? Before I change the screen. Look at this, you guys. I'm a messy writer. This is very clean. It's so hard for me to write neatly. Like when I see stuff like this, I'm very impressed with myself. Just letting you know. All right, let's go back to sharing the screen. So hard when I can't see your body language. Are you guys rolling your eyes at me or anything? What the heck slide are we on? Oh, here we go. It's the last slide. Let me when you're done. Let me when you're done. Let me know when you're done, please, Kate.
Done.
Thank you. Anybody else still writing?
Yep.
I'm still writing.
What the heck? Pick it up. I'm just kidding. You guys, I was gonna say you wouldn't have me muted. I hope parents aren't thinking I'm yelling at you. Don't know me yet. We were talking about instantaneous versus average a little bit when I was pointing out kind of the tangents on a curved graph. Instantaneous would be kind of at that moment, at a specific time, where the average is over time. This is all I got for you. I'll stop recording, but I won't kind of close the Zoom channel. I think it'll shut down itself if there's nothing going on for 20 minutes. But feel free to stay or go. You can work and stay kind of on the channel. And then if you have questions, you can ask, or you can go and then just come back if you have questions, whatever works for you. But I think I'm going to stop recording are there any questions? All right, then I'm going to stop recording. And I was asking when people are done, but you know, when you're done, this is the last slide. So, okay, no questions. I'm going to stop recording. And if you go, I'll see you. No, after lunch, that's when I'll see you. I don't know how to stop recording. Is anybody still writing? Because I have to go back to the other screen. No. People are bailing. All right. Stop share.